All right. Hello, everyone, and welcome to yet another Cosmos Community webinar. My name is Jonas Roslin. I'm the Director of Community here at Vast Data, managing the Cosmos community. Super happy to have you all here. Really excited about today's talk. So today we have Guy Salton joining us from Run AI. Guy, you're the Director of Solutions Engineering at Run AI. What do you do there?
Yeah, thanks, Jonas. Great to be here. So I lead and manage the global solution engineering team here at Run AI. So our team helps onboard new customers. We handle the software implementations, installations, training sessions, technical demos, things like that. So we're a field team. We work a lot with our customers to understand their use cases and see how we can bring them value with our solutions.
Fantastic. So I'm super excited about your presentation today, architecting the AI lifecycle in financial services, accelerating workloads with GPUs and fine-tuning LLMs for customer-focused solutions. If you're watching here and you have any questions, please use the Q&A function here. You can also send us messages throughout the presentation, and we'll finish up with the presentation. We'll finish up the presentation with a Q&A at the end. But if you have questions throughout the presentation, please let us know and just fill it out. And with that, I'm going to hide myself, and the floor is yours.
Thanks again, Jonas. And thank you all for joining. Great to be here. So I guess we can kick it off, and I'd like to start with talking a bit about the main challenges that we see in the market, in the field, for especially for our financial services customers when they try to, get into AI and build and scale the scale AI solutions in their organizations. First thing that we see is it's quite a challenging thing is serving a growing user base, and that can mean both internal users, building solutions inside the organization. This can be an investment bank, for example, but also external users, right? When you have these AI solutions in production, and you need to handle model serving and make sure you get the right SLA to the external customers using these applications. And we'll talk about that. Another thing we see is, sorry, I have a typo here, but it's supposed to be supporting many type of workloads and many type of tools. So especially in financial services, but we see it in other verticals, to attract top talent, you don't want to force your employees and engineers to use one specific tool. They might want to use the tooling of their choice, frameworks of their choice, and you want to be able to support all these different tools and frameworks that your different engineers want to use. And that can be a challenge as well, and we'll see that in action. And the last part is orchestrating the full AI lifecycle. And when I talk about that, I really mean the main challenge is what we call shadow AI. So especially in these larger financial organizations, you might have many different projects and many different lines of businesses that want to start working on an AI solution, and they need access to compute resources. They need to start running their workloads and use the tools that they want to use. How, as an organization, how do you orchestrate all these different projects and all these different silos, and how do you make sure that the right amount of compute is accessible to the projects that needs to access it when they need to access it based on your organization's priorities and policies. So this is a bit about the challenges. Now, why use GPUs at all? And we know that was in the first slide, right? We said we're going to see how you can how we handle these in financial services organizations, specifically for GPU workloads. So this is it's not a new thing. We all see the Nvidia stock booming. I think yesterday it was the biggest company in the world in terms of market cap, and that's mainly because of GPUs, right? And GPUs can be extremely beneficial in financial services as well, because they can both accelerate your existing workloads, and this can be kind of more traditional workloads that need to handle structured data. So things like risk management and trading, more traditional algo trading systems, but also help you unlock new ones with kind of more challenging unstructured data. And this is where generative AI comes in and can help for like wealth and retail services. You can have LLMs or for alternative data and handle other investing services. So GPUs are beneficial. And on the other hand, right, we have the actual AI workloads that the researchers needs to run. There are different types of AI workloads that needs to run as part of the AI model lifecycle. And each of these type of workloads, each of these stages has different requirements. They all need access to compute resources. They all need access to GPUs, but with highly variable demand patterns. For example, data pre-processing. This is where you can think about it more as like in the beginning of the cycle when you need to work on your data, manipulate the data, label it, and clean it. So this would usually be in running in like data pipelines and workflows, more kind of like batch workloads that might need to access GPUs. Then you'd enter the stage of the model development, actually developing the model. And this is a completely different type of workload. This is more, think of like an engineer and a researcher that needs to interact with the model. So he needs some kind of IDE, like like a coder, and he would write some code. He would do some debugging. He might need access to some GPUs when he does that, but it's not very intensive. And he might, run some commands that actually use the GPU, but then the GPU might, not be actually needed, might sit idle for a couple of hours. And then after the model is developed and ready to be trained, the actual training process, this is also a very different type of workload, because this is a batch workload that uses massive amount of compute of GPUs, of course, depending on the size of the model. And this type of workload will highly utilize the extensive compute that it runs on for a long period of time. This can be hours, can be days, it can be months when you're talking about the huge LLMs like Meta's Llama or Falcon or Mistral. All these huge LLMs can take many weeks to train. And finally, after the model is trained and fine-tuned, and you want to start serving and have customers being able to access it and prompt it, this is more kind of like a production application. So this is, you want your model to be able to go live and have access to compute, but again, it might sit idle for a couple of hours only when a customer tries to access this application and use it. This is when you need it, but this is, again, a production type of workload. So when somebody actually needs to, sends a prompt, he needs a response immediately. So this is where SLA is extremely important. And so we said we need to handle this orchestration. We need to support all these different type of workloads for different types of use cases. But the problem is that, and we see this a lot in the industry, when companies, and this is also true for financial services, when they start looking into getting to AI, they usually start with like the top of the iceberg here. So they start with the data, they start with experiment tracking, they think about model security and things like that. But just below the water level is a very important layer that without it, everything would kind of get stuck. Like you won't be able to do much. And that's the resource management level. So this is where, as an organization, you might build a data center, you have some on-premise cluster with GPUs, or you might be using the cloud. How do you make sure that the different projects within the enterprise, the different organizations, has access to the right amount of compute, to the right amount of GPUs when they actually need it? So this is the resource management layer. And you can see in this slide here that this is real patterns from one of our customers, and it shows different types of workloads and different types of projects within the same organization, and how the access to GPUs and the usage of GPUs for this project, how it looked like over the period of a few weeks. So you can see that the patterns are very, very different from each other, because like we said, you might have one project that's still in kind of like the model development phase. So they might not use a lot or barely any GPUs for a week or so, but then they entered the training phase. So for a few days, it might not be a long time, they might need access to a lot of GPUs, right? And after that, they might start serving, so they need a few, but for a long period of time, where maybe this project entered the training phase already. So in the first week, they needed to had access to a lot of GPUs, but then maybe start working on something else. So you see, it's very, very different. And what this means is that you need a smart, dynamic orchestration layer that will allow and understand the priorities within the enterprise, and how to make sure that this project gets all of these GPUs on this week when it actually needs it. But when it doesn't need it, you can allocate it to a different project. And so for that, we built the Run AI platform. Run AI is an AI platform. Here we're going to talk about financial services, but of course, it works for any vertical. It can be gaming, healthcare, defense, and so forth. And so when you think about the enterprise, you have your business drivers. And when you're talking about financial services, this can be trading and investing, or intelligent automation. Then you feed this in to the platform. And the way that it looks like is you can see the type of workloads that we mentioned earlier here in the top, right? Then you have the software layer of the actual NVIDIA software and libraries that you can run inside your workloads. But just below that and above the actual hardware, right? Here you can see the actual GPU, CPU, RAM, and data. This is where like vast data can be plugged in as a storage layer. Just above the hardware, this is where Run AI sits in. So this is where we sit in the stack. Run AI is an AI workload orchestration platform. So it handles the resource management, right? This layer that we saw on the iceberg slide just below the water level, and provides an advanced AI workload scheduler. So you can set policies and priorities. You can have quota management, and to be able to best and most efficiently support the different AI initiatives within your organization, and make sure that every project, every researcher gets access to the amount of compute that he needs when he needs it. And with this solution, we help customers with these challenges. And this is another pattern with real data that we got from one of our customers, showing how with adopting these scheduling techniques and capabilities, allowed them to run many more workloads, many more jobs over the course of 9 weeks. So almost more than 4 times the number of jobs that they were able to run before. And this is with the same infrastructure. So without buying new hardware, without buying new GPUs, they were able to run many more jobs and utilize the existing GPUs that they have in a much more efficient way. So just get a much better ROI on this very expensive infrastructure. So to kind of sum up the slides, of course, we will go into the exciting part, which is the demo. And you'll see this all live in action. But in Run AI, right, we said we have the workload scheduler, the advanced scheduling layer. on top of that, it's a fully enterprise ready solution. So you have enterprise visibility and control and controlling visibility. You can set policies. You can plug it into your identity management systems, and you can create templates and make sure that each user is restricted to only the areas in the environment where you should have access to, etc. So we talked about that. Now let's talk about what we're going to see in the demo today. So what we're going to see today, and this we mentioned in the first slide, is how you can fine-tune Llama 3.1 8 billion parameter model. That's kind of like one of the most popular open source models today by Meta. We're going to train it, right? And we'll talk about what fine-tuning actually means, but we're going to train Llama 3.1 on a data set. And this is a data set that's related to financial services, right? Because Llama model is a generic LLM. It was pre-trained by Meta on huge amounts of data, but so it has the basic understanding of the language, but it's not designed specifically for financial services. We want to make sure that we feed it, we train it again on a data that's relevant for our organization, for our use case, so it would be more accurate. So it would have better answers, better performance for our use case specifically. And then we'll see how we can deploy the fine-tuned model on a GPU and prompt it live. So we're going to use this GitHub repository, and it's public. You'll be able to use it as well. And we'll share the recording with you. And this is an open source again project that we worked on. Ekim from Run AI did some really cool stuff here. So the main page here of the GitHub repo is running this fine tuning on a single node. We'll actually see a more advanced example in this webinar on how to run this fine tuning workload as a distributed workload running on multiple GPUs as a batch workload. And we're going to use something called LoRa. So LoRa is a technique that's designed to make fine tuning more efficient. We won't get too deep into LoRa, but basically what it does is it freezes some of the parameters, some of the weights, and it only trains a subset of the weights that are relevant for our actual use case. So it ends up creating smaller fine-tuned checkpoints, which makes it more efficient and effective. And you have a link to the paper here if you want to know more about LoRa and understand a bit of the math around it. The data set that we're going to train the Llama 3.1 model today is also linked here. It's the Alpaca financial data set. And basically, like we said, Llama 3.1 is a generic LLM. We want to fine-tune it to train it again on data that's relevant to our use case. And as we are talking about financial organizations, we're going to feed it. You see how this data set looks like. It's basically hundreds or a bit more of instructions and desired outputs. So you can see some of these instructions. This can be questions like, why does a stock price drop as soon as I purchase several thousand shares, and you can see the desired output. So we're going to feed this to the model. We're going to train it again on this data. So then when it's trained and we deploy it, we can prompt it with a new instruction that it never saw before, and it would provide us with a more accurate response than just the generic Llama 3.1 model. So this is the data set. Now we can jump into Run AI and start doing things live in action. So this is Run AI here. This is the Run AI UI, and we can see we have some workloads running already. But before we start running workloads, we just want to see our environment. So we see we have the resources section here. we can look at the nodes. I have one cluster here, and I have multiple nodes on this cluster. We're going to focus on these 4 nodes. You see, I have 4 nodes here that has one NVIDIA A10G GPU each. So the NVIDIA A10G GPU has around 24 gigabyte of GPU memory, and this is enough to fine-tune the Llama 3.1 model on this data set, as well as to deploy the fine-tuned model once it's ready. So this is our environment. Now let's go back to the workloads and see what's running here. So remember, we talked about the need to support different types of tools and frameworks. One very popular tool for the model development phase is Jupyter Notebook, but you also have you have alternatives like using VS Code or PyCharm or others. We support all of these popular IDEs, and I already have a Jupyter Notebook running here, and it has a PVC, a data source linked into it. So you can see that if I go and just click on connect here from the UI, it would bring me into our Jupyter Lab notebook. And inside this notebook, I have my GitHub repo already mounted here. So you can see that once this loads, let me reload it here for a second. Okay, might take a few seconds. It was just about to load. Okay, yeah, okay, it should work now. So we'll see the Jupyter Lab notebook UI, and here, let's see what's going on here. See if I can be clear. Okay. Not sure what the problem here is. Let's clear the workspace, maybe that will work. But basically, this is an interactive development environment that has access to all the GitHub repository folders and files that we saw here. And I was supposed to explain about these different files. We can also do it from the GitHub repository directly. Okay, now it's up. Demo gods are not with me today, I guess. Just ran this just before the webinar and everything was fine. Last chance. Okay, we'll start working. Okay. Let's start looking at it here at GitHub, and then we'll try to get back to the notebook. So we're, like we said, going to run it as a distributed workload. Inside this distributed directory here, we have 3 files: the Docker file, the launch.sh script, and the distributed.py Python file. Okay, now it's loaded. Great. So these files here, and let's start with looking at the Docker file. Okay, so the Docker file is what creates the container for our workload. You see that it starts with installing some Python dependencies like Torch and Torch Vision, transformers, etc. It then sets a working directory as the demo directory. It copies the other files into the demo directory, then creates the checkpoint directory. This would be where the output of the fine-tuning workload would get stored in. And it finally goes and runs the launch.sh script as the entry point. So let's take a quick look at the launch.sh script. And we can see this is what would actually get launched when the container starts. So what we see here, and again, as this is a distributed workload in Kubernetes, the way that it works is you have the Kubernetes networking layer, and this is where we define the master address and the master port. You have the world size and rank, and these parameters basically support us when we want to scale up and down a distributed workload. So whether we run this workload on 2 GPUs, 3 GPUs, 4 GPUs, these parameters would allow us to go and do this scaling and adjust the script accordingly to support exactly the amount of GPUs that we'll run on. And then finally, the actual execution command is the torch run command. So we're going to pass some arguments here, like the number of processes per node is going to be 1. As you saw, we only have 1 GPU per node. So that means that we'll have 1 process per node. Then we have the number of actual nodes. The rendezvous endpoint, this is kind of like the distributed protocol that we're going to use, and pointing to the master address and port. And then finally, you see that this would launch the distributed.py script. So this is where LoRa and the actual Python code is happening. So once we reviewed all these files, by the way, as I mentioned, we have a PVC mounted into this notebook. It's the same PVC that we're going to use for launching the distributed workload. So that's cool because I can make changes to the script here and add files, etc. And this would be available automatically to the distributed workload. So it's just a great way to show the different stages of developing and building AI solutions, right? You start with the notebook for model development, then you go ahead and run the actual training, and then we'll see the inferencing at the end, the model deployment. So now let's go and run this actual fine-tuning workload. So we'll click on new workload. This would be training, right? We want to train Llama 3.1 on the financial data set. And we're going to choose distributed as the workload architecture. We're going to use PyTorch, but you see we support other distributed frameworks as well, like MPI and TensorFlow. We're going to support, we're going to choose workers and master. So we'll have one, we'll see that again. We can call this workload a name. We can call it fine tune Llama. Click on continue. And now we need to choose the actual environment that we're going to run. So this is basically a Docker image that we will run. So this Docker image contains some basic dependencies like Python and PyTorch, etc. And we're going to choose the number of workers. So we're going to have 1 worker, but we're going to have a master as well. So each of them will act as a worker. So we're going to have 1 GPU for each, so a total of 2 GPUs, right? Choose the amount of compute per worker, and then select the data source. So this is the actual data set that we have stored in a PVC, and we can click on continue. So what will happen now is you see we have a new distributed PyTorch training workload running. It would distribute across to 2 different nodes. Each node, right, have 1 GPU. So we have 2 processes, each allocating 1 GPU, have access to the data set. So the data set would get split between 2 of them, and it would start fine-tuning our model. And we see that the containers are already running. We can go and look at the actual logs and see that indeed it is now starting. It's starting to load the model. And it usually takes a few minutes until the model is actually loaded into the container. And then we'll start seeing the work happening. We'll start seeing epochs here, etc. Then we can also look at the metrics and see the GPU utilization, the GPU memory utilization, the CPU throughout the history of this workload. So this is now running. It can run for about an hour or so. So we won't be able to wait and see it complete, but it is running. Now, just to also show you how the final stage would look like, we can talk about inferencing, we can talk about model deployment. So let's say we waited now until the Llama 3.1 model is now fine-tuned on our data set. I already deployed the fine-tuned model that I fine-tuned before this webinar, and it's running here. And we even have an easy way to launch a chatbot UI that's connected to our model that's running. So with one click, I can just go and connect to the chatbot UI, and I can start prompting. I can start asking the model questions, and these can be financial questions like we saw earlier in the data set, right? So getting back to the README here, right? The model is now trained on all of these instructions. We can go and send it a new instruction and see the response live. So yeah, now the chatbot UI is loading. It's pointing to the trained Llama model that we trained on the financial data set. And once it's up, we'll have our text box and we can start sending prompts. I think my internet is just a bit slow here today. And that. Once it's while it's loading, we can go back and look at our workload, the fine-tuning workload that's now running. We can see the metrics. So currently, yeah, you see the CPU usage is rising, CPU memory usage is rising. Once the model is fully loaded into the GPU, will spike. You see it's already using some of the GPU memory, but we'll also see a spike in the GPU compute utilization. And again, we can look at the logs of each of the pods. So you have both the master and the worker. You can toggle between them. By the way, running workloads can be done not only through our UI, but also through CLI and API for those who prefer that. And we have some customers that prefer running, especially these batch distributed workload just through CLI. Find it easier. Let's try to refresh the chatbot UI here. And I hope I can show you this in action. And again, while it's loading, we can also see like the actual flow. So we saw the flow, we did it together, right? The actual running out of the fine tuning, the distributed training workload. But for the inferencing, what I did before the webinar is I just chose inference. Then you can either choose a custom model. This is what I did because, you know, I create once the fine tuning completed, I had my new checkpoints. I then packaged this and as a new Docker image, and I can then deploy it as a custom model. But we also have an integration with Hugging Face, so you can go and deploy other models like Falcon or Mistral or whatever, and so just provide your model name from Hugging Face, your Hugging Face token, and we would automatically pull your model from Hugging Face without even knowing anything about how Docker works or containers. So we provide this layer of abstraction. You see, you just provide your model name. So for example, if we go to Hugging Face and we look at Llama 2, 7 billion parameters, and we can paste the model name here. We can then paste the Hugging Face token. Let me quickly show you that. Right, so I'm pasting the token, and we see we even kind of recommend the amount of GPU memory that you need. So for the Llama 2, 7 billion parameters, 12.67 gigabytes of GPU memory is enough. So you can only allocate the amount of compute that you actually need and run your model on a fraction of a GPU, leaving the rest of the GPU available for other workloads, and just click create inference. So that's a bit about the flow. Now let's see if the chat UI is ready. If not, we can maybe try to deploy it again. But it's basically just like the chat GPT interface that you're all familiar with. We can try to deploy this one again. So get the name Llama 31 8B inference. To deploy the chatbot UI, I can just click on new workload, workspace, and call it chatbot. Any name would do. Click on the chatbot UI environment. And as for the runtime settings, I need to set my workload name. So let's see this again, make sure I'm running it correctly. But this would be, yeah. Yeah. Yeah, the Llama, we can look at it here. Yeah, and use the news research, Meta Llama. Yeah, we can see it in Hugging Face. Yeah, so look at this project, and then it's Llama 3.18B. Yeah, that's the meta version. Yeah, okay. That this one, the 8B. Okay, yeah, this one. So let's go and set it here. Then the workload name, that would be Llama 31 8B inference. Llama 8B inference, right? Capital B. And the project name, which is P1. And this environment variable I don't need, and they can just run on a CPU. And we'll now deploy the chat UI, and we'll see if we can now access my my deployed model, so I can show you a live prompt. Okay, now it's running. Let's see if this would work now. And if not, it's not a big deal. We saw the fine tune, which is with the main could be an internet connectivity issue. Cool. Okay, so to kind of sum up and understand what we did here, right? We saw how we can orchestrate our AI infrastructure and allow different types of workloads to run with different requirements, fine tune a real open source model like the Llama 3.1 on a financial data set, and then deployed. And with these type of implementations and solutions, we are able to help a lot of different Fortune 500 companies, both in the financial services vertical as well as others, help them support thousands of users, save millions of dollars a year on cloud spend, just because we saw that you can better utilize GPUs that you already have. You might not need to spin up and use additional ones, so you can save a lot of money with that, better ROI on the infrastructure, and with the right allocation to the right projects according to your business priorities, get much faster time to train and models to production with zero internal manual interventions. So thank you very much. Let's see if we have, I think we'll eventually go, but let's see if we have any questions. I'll stop sharing my screen now.
Yeah. So thank you so much, Guy. Really cool presentation. And yes, the demo gods weren't really with us today, but that's perfectly fine. If you have similar demo or something like that already recorded, we can link to that when we post this as well. Want to make sure that everyone understands everything. So I got a few questions for you, and I'll start with the training questions and then some general questions. When it comes to training, so you were training you were fine tuning the LLM by creating a LoRa. Is that right? So
LoRa is the technique that we used for fine tuning, right?
Yep. So if I was to fine tune on the same data set and using the same model and everything, would we get similar outputs? So if we were to compare our trainings, they were done completely the same. Would we get similar output?
Yes, so you would get, if you're training the same model, right? So the Meta Llama 3.1, 8 billion parameters model on the same data set, yes, you would get the same checkpoint, the same output for that. But then, so it's the same model was trained on the same data set. Yes, so basically it's the same, would you get the same results?
Yeah,
you can of course retrain it again on additional data to get better results, or if you want to focus more, or you have additional data, you can do that again, right? It's not something that you only do once and leave it forever, right?
Yeah, this is great. This is great. Let me see here. Chetan has a question here. Are there any limits in terms of scaling? That's on your side, I would imagine.
Mm-hmm. You mean on the Run AI side? So we support some of the largest AI deployments in the world today, and so I'll give some numbers just to see if that's around the scaling that you're looking for. But we have some of our biggest customers are managing thousands of GPUs per cluster, but they have multiple clusters. So I think our biggest customer today might be managing more than 10,000 GPUs overall, around more than 1,000 nodes per cluster. So around like 4,000 GPUs per cluster, with hundreds or thousands of users using, again, plugged into the organization identity management with RBAC and policies. So yeah, working at very high scale today, both on cloud environments as well as on-prem environments.
Awesome, thank you. And Chetan responded here with a thumbs up, so it seems like that was exactly what he was looking for. When it comes to fine-tuning models, and you said to continue to fine-tune them to get even better results, what would you recommend? Would you recommend to retrain a model multiple times, or would you have a standard model like the Llama 3.1 8 billion? would you use that together with a RAG, or would you rather fine tune first and then add a RAG with all your content?
So that's a good question, and we didn't talk about RAG today, but RAG sometimes seems like it's in an either or question. Should I fine tune my model on my data set, or should I build a RAG pipeline? And to be honest, just to explain what RAG is, so as opposed to fine tuning, which we saw on today's webinar, right, when we take a generic LLM in this case, and we actually train it again on a data set that's relevant for our use case. Again, we saw that this training requires, compute power, right? So you need access to GPUs. It can run for multiple hours, sometimes more, of course, depending on the size of your data set. So it is a bit more complex, maybe, or requires a bit more of expertise as well as access to compute, etc. But at the end, you find yourself with a model that's already trained on the data that is relevant for you and is ready to use, as opposed to RAG, where RAG is you feed the model with kind of like up-to-date data, but on the inference stage. So you don't train it again, right? You just on the inference stage, instead of just for the model to just like get the prompt and response immediately, the model can then go and look at a new set of data instructions and then reply after it learns from this data. So I think a strategy that can make sense is maybe start, and this is what a lot of organizations are doing. They might start with just like a generic service, like just using ChatGPT or some large model. Then when they want to do something a bit more advanced that's more relevant for them, they might take a generic model and build a RAG pipeline internally and feed it with up-to-date data. And maybe the last stage would be the fine-tuning. When you feel a bit more comfortable, when you already have your RAG pipelines in place, and now you're ready to make the next step and actually fine-tune your model and have the end result, the checkpoints designed especially for your use case.
Awesome. Yeah, I think that's a great answer. You were talking about training and inference, and in one of your slides, you showcased GPU allocation and usage as well, and how different teams from the same organization were using GPUs at different times in their projects. We had an interesting conversation in the Cosmos community earlier this week regarding power usage and power consumption as well, because that's a topic that is very hot right now when it comes to, well, how do I design my next data center, or what should I aim for when it comes to power usage and power consumption when I want to deploy AI in-house, for instance. So what are some of the things that you have had to deal with when building out Run AI and making sure that you can handle the different workloads at different times?
Sure. So I think just to touch on like power consumption, it is a very hot and big topic, and I think for people that are interested, I saw there's like a few videos that people uploaded about showing the new XAI supercomputer in Texas and all the liquid cooling systems that they're using there, because obviously power consumption there is insane. When we built Run AI, we built it with the understanding that we will see AI environments getting bigger and bigger and needing to support more and more teams within the enterprise that we would need to get access to compute. So that's kind of like our core technology is the scheduling layer, the orchestration layer, because like we saw in the patterns slide in the deck at the beginning, different teams might need to get access to GPUs at different times, right? Maybe if I'm a researcher, maybe today I want to run 20 experiments and I need access to 20 GPUs, and tomorrow maybe I'm doing something else, or I'm doing some research and I'm maybe only using CPUs. So static allocation it just doesn't work. So you need a dynamic orchestration layer that would have that, and so that's kind of like the core of running. This is where we started. We saw that Kubernetes by itself, just the default vanilla Kubernetes, but also any variant of Kubernetes, whether this is the OpenShift or Rancher or the cloud versions of it, like EKS or GKE, etc. They all come with a basic scheduler, right? It's not designed for AI workloads, really. It's designed for deploying microservices on CPUs. We want to tackle this important and difficult challenge of orchestrating GPU workloads on Kubernetes and making sure that different teams, different projects within the enterprise get access to the right amount of compute when they need it. So yeah, there's a lot of different logics and algorithms that we built into our scheduler. Of course, we'd love to talk about that for anyone who's interested. But yeah, not really the focus for this webinar. Yeah.
That's a great deep dive, I think. So Chetan has another question for you here, and I think that's the last question for today. So when you look at all those graphs, can you trend out and forecast capacity that's needed? Yeah, that's the question essentially.
Yes, so that's a good question. If I understand it correctly, that's something that a lot of our customers are looking for, because they start with doing this investment in AI infrastructure, right? They buy a lot of GPUs, they set up the data center, they invest a lot of money. Then they decide on organizations' priorities and policies, but they want to also monitor the system and see that people are using it and see who's using more and who's using less, and shifting priorities based on that. So capacity planning is something very important. Billing is something very important, right? We have customers in the EDU space, for example, where the IT department are actually charging the different research groups based on their consumption. And this is where they also, so we also provide monitoring and billing dashboards and consumption-based dashboards that allows you to keep track and visibility and monitoring into the usages of different projects, and also help you with our professional services team on how to use this data for capacity planning, how to plan ahead, and how to allocate resources for the next project, for the next quarter.
Fantastic. So Guy, as we wrap up here, can you tell us where we can find Run AI, where we can connect with you if we have any more questions?
For sure, yeah. So you can go to our website, which is very straightforward, just run.ai, and read all about us. You can request a demo through there. I'll paste my email address as well, which is just guy@run.ai. And we're also going to be in a lot of it's conference season coming up, and we're gonna have a big booth in supercomputing conference in Atlanta, Georgia, which is in just a couple of weeks. Then in KubeCon conference in Salt Lake City, I think it's just the week after that. So you can also find us there if you're coming to any of these events.
Fantastic. Thank you so much, Guy. And thanks everyone that has been a part of this webinar today. We're looking forward to having you here next week as well. Next week we have Kristen. Next week we have Kristen Thompson talking about vast customer training and enablement. So tune in for that. And with that, thank you everyone, and have a fantastic rest of your week.
Thank you guys. Thanks for joining. Bye-bye.